My name is Lara, and I'm going to be presenting the difference between COVID-19 and Corona for my final lab project in Mrs. Odapali's class. So, what's the difference between COVID-19 and Corona? Okay, so if you look here on the PowerPoint, on the left side, you're looking at COVID-19, and on the right side, you're looking at N163. Now, if you're thinking that they look similar, that's because they do. Now, if you'll look at it very closely, you'll notice that while they do look similar, they are not exactly the same. That is because COVID-19 is a strain of Corona. So they're in the same family, but they're not the same thing. They have key differences, which we'll get into later. So another type of Corona strain is the flu. One of the main similarities between COVID-19 and Corona is that they both are respiratory infections. So another strain of Corona is the flu, as you can see in the picture. Again, they are very similar, but they are not the same, which is what you have to keep in mind when you're thinking about these two things. It'll help you remember. The first thing that I'm sure everyone knows is that COVID-19 is far more dangerous than most respiratory infections, such as the common cold, the flu, etc. Now, while some of the key features, which are fever and cough, are similar to ones that you would get when you have the flu or a cold, what makes it so dangerous is that they range in severity. So if you think about when you have a cold, you might have a cough, but it's not a super bad cough that makes you, I don't know, cough up blood or excites an asthma attack if you have asthma. With COVID-19, the symptoms can range from mild to extremely severe, which is why it's so dangerous for people with underlying conditions and even some people without underlying conditions who have fallen ill because of this. Another difference between COVID-19 and other strains of coronavirus is that coronavirus spreads easily and sustainably, which is also known as community spread. Community spread is when a geographical location gets ill from the same virus, even if, let's say, I got it and then a neighborhood over someone got it, even if that person didn't know where they got it from or how they got it, that would still be considered community spread because we all live in the same geographical location. Now, that is one of the key differences between COVID-19 and other strains of corona that is not common with the flu or the cold. If I get a cold in a week, my neighbor in the next neighborhood will not also get the cold. It would be very uncommon, and I'd have to be all in their personal space for that to happen. So another difference is that there are generally vaccines for other strains. Like the flu, there are vaccines for the flu. You go every year. And for coronavirus, that's not the case, which is what another thing that makes it really dangerous is there isn't a vaccine out for it currently. Now, is corona a virus or a bacteria? Now, in the beginning, if you've heard the full name, it's called coronavirus. So that should give you a hint. It's a virus. Now, the key differences between a virus and a bacteria is that bacteria can be treated with antibiotics. Now, the antibiotics don't need to be changed. However, the bacteria can grow resistant to the antibiotics. So you need to be careful when you're taking antibiotics for an infection or something similar to that. However, the bacteria itself does not change. Whereas when you have a virus, viruses are constantly evolving and they change very quickly, which is why every season a new vaccine comes out for the flu. The flu is taking my flu shot is one of the ways that I keep myself safe from COVID-19 because I have underlying conditions. So making sure that I keep up to date with my vaccines keeps me from getting ill in the first place so that I can stay safe from COVID-19. Now, viruses also need a living organism to replicate. They need it to stay alive and to survive and to reproduce. Now, the structural format of coronavirus is very complex. So coronavirus encodes several different structural and non-structural proteins. What does this mean? This means that there are several different proteins and structures within the coronavirus. Now, all of the structures and proteins do different things. However, the one that I'll be explaining to you right now is the spike glycoprotein. That's at the very top of the PowerPoint. If you're looking right about here, the yellow part on both the left and the right side. So the right side is like a bisection, like a cross section, and the left side is a whole view. Now, that is the protein that is responsible for host infection. That's why I said it's the one that I'll be explaining what it does, because it's responsible, it's what gets you sick. Now, the other proteins do different things, and it's a little bit too complicated to get into right now. Now, how is a vaccine created? So, under normal circumstances, it can take about 10 to 20 years to create a vaccine. Now, because of the general state and the pandemic, things can be expedited so that more resources can be pulled into creating vaccine. So generally, there's only about, I'd say, 5 to 10 labs working to create a vaccine. However, when more resources are pulled into it, most of the labs can be working on it. As you know, many different countries have been working on vaccines. It's an all hands on deck type of situation. So, how does this work? During the exploratory stage of developing a vaccine, what happens is researchers and scientists will work to understand the disease, how it works, how it replicates, and how to kill it off, and what different things affect it. This leads them into the preclinical stage, where they will get out all the kinks and stuff with the vaccine to make sure that it is safe to test during the clinical development stage. Now, clinical development is usually when clinical trials start, when they have volunteers come and test out the vaccine, explain to them, report back the symptoms that they have so that the scientists can better understand how to regulate and the dosage that they should try to imply when they get to the regulatory review and approval stage. Now, this stage is where they will put rules and regulations on dosage, on time of day you should take it, whether you should take it with food, based off of what the information that they gathered during the clinical development stage. The next stage is manufacturing, where they will mass produce the vaccine in order for the general public to have access to it. And then the last stage is quality control. The way that I stay safe from different viruses, bacterias, corona, COVID-19, is washing my hands, making sure to stay up to date with my vaccines, getting antibiotics if I get an infection, making sure to stay 6 feet away from other people, wear my mask, stay in groups less than 10, following the general guidelines. Thank you.